Okay, so today we're looking at data subsets, and I designed this script. I tried using any of the R data sets, and I felt I should use Iris. Though of course, after this class, we can all, I believe we all know how to access the various data sets in R. So we should be able to try this out with various data sets, be able to extract data. So one may ask, what's the need to know about data subset? R is actually designed for working with large data sets, where you have a large data that is plenty, that's it will be too cumbersome for spreadsheets programs like Excel and all to handle. So R is able to handle it because you're able to tell R to extract subsets of data for you to use to work with, to analyze, to do analysis you want to do on that subset of data. So today, we are going to use the Iris data set to extract specific parts based on various R commands that we will use. So for line 6, 7, and 8, of course, this is a view. We're using the view command, the view function in R to view the Iris data on the script. So if I should run this, the Iris data set will open on the script. I believe we've already passed through this stage. Then if I click 7 or 8 at the same thing, if I should run line 7, it will appear on the console. And if I run line 8, still the same thing. So line 7 and 8 are the same ways to call up any data set to be shown on the console. So we now move to using base R functions to extract data from any data set. So we start with the dollar operator. I know I've used this in some of our previous classes to extract data. So we can use the dollar operator to extract specific columns as vectors. I believe when I say vector, we should know vector different from data frame, different from arrays, different from lists. So these are various data structures in R. So if we use the dollar sign, we are telling R to go inside this data inside this column or variable and bring it out as a vector. So now if we run this Iris dollar species, so we get this vector being shown here. And if you look closely, you can see that it's actually it has levels, because it's not just a vector, or it is a factor. When it comes to vector, we have a specific type of vector called factor. So that's why you see levels, setosa, vesicolor, vesinica. Levels become important when you want to, draw graphs. So for just the data handling, vector factors don't really have any much importance. So, but when you want to draw graphs, when you define the levels like telling R how to arrange the diagram based on this one should come first, this second, this third. So that's where vectors and levels come in. So okay, so that's all for using the dollar sign. So now we now go to line 18, where we look at how to extract data using the square bracket operator. So this one gets a bit more complex because it allows the use of if you remember beginning classes in R, Okay, before I continue, let me ask any question on this dollar operator so that should I take it gradually? Anyone have questions based on dollar operator function? Okay. If I don't get any question, so please feel free to cut me short at any point. As I earlier said, this is meant to be interactive because it's getting more complex as we go. You know, from here now, I hope after this class, next classes, I hope we'll look at how to work, how to remove, how to identify outliers. Then after that, we now do data wrangling, how to wrangle data. But we now go into, you know, data analysis using statistical tools and also using graphs, visualization. So these are quite a lot. So it's good we all go through. Okay, yes, Doc.
Can you repeat line 14 again? Explain it again. Iris, dollar, stepper, one lens. Can you just recap it again?
All right. Okay. Now, okay. To make it clearer, let me open let me run line 6. Okay. So if I run line 6, this is what will come up. So we see that this array data, it has from here you can see it has 5 total columns. You see 1, 2, 3, 4, 5. You know, you have separ.length, separ.width, petal.length, petal.width, and then species. So these are the columns or the variables. Okay. Now, if you go back to our tutorial, so this line 14 is telling is Irish dollar separ.length. So it's like telling R, okay, extract, open up the iris data and then extract this column called sepal.length. So if you look at here, you can see it is the first column here, sepal.length. So I'm only telling out to just give me this value. So from the first one, that is 5.1 down to the end. Remember that there are 150 rows or entries or cases in R. So that's basically what we are doing. So R just extract this as vector, as we can see when we run it. I'm trying to bring it up. Okay, I think we ran it. So let me run it. Sepal length. So if I run this, so you see, it bring it out. So if we now okay, let's compare. You see, the first one is 5.1 followed by 4.9 and then 4.7. So we can see 5.1, 4.9, 4.7. So you can see, so R has budgeted out as a vector. That's why it is like this. It's no longer in this form. No, this is the data frame format. Now this is a vector. So this is the first one. This one is the 24th one. If we compare, okay, what is the 24th one? The 24th one here is 5.1. You see, that's the same thing here. And the 70th one here is 5.6. If you take 70th one here is 5.6. So R had just extracted that column of data as a vector for you to use whatever you want to analyze based on that alone.
Thank you, sir.
Thank you, Professor Chinyere, for the question. So any other question based on this dollar operator? Okay. In the absence of any other, then I'll go ahead. Okay. So we're now going into the square brackets operator. And for the square bracket operator, so it's a bit complex. So, but I'll try to break it down so that we understand what it is about. The square. Sorry, have you? Okay, so the square bracket operator is designed such that you can extract only a column, or you can extract only a row, or you can extract both columns and row as a data frame. Okay, but for it to extract a row, that means it has to be also a data frame. That means one row and several columns, or one row, one column. So the square bracket gives you more flexibility to tell R what you want. So it has a lot of commands that can be used. You can see from here, the square brackets took up onto here because there is a lot. So these are the ones that I could show. You can practice it later in your private time to check it out. So now for line 19, you can see that I wrote the iris square bracket open, comma, 5 square bracket close. Now, understand this, that when it comes to square brackets, once there is a comma, it tells R that for the comma, anything to the left-hand side is referring to the rows or cases. Anything to the right-hand side refers to the columns or variables. I repeat, if you want to subset using square brackets and you want to use the comma, then that means you want to define to R the things you want as rows and things you want as columns. Where you don't put the comma, then R sees it as you are defining only columns, just like you're using the dollar sign, just like you can see line 22 and 23, there is no comma at all. But if you watch every other one, there are commas everywhere. So for line 22 and 23, you just like using the dollar sign. So the kind out to just extract a specific column. So now going to line 19, remember I said that for square brackets and with comma, the left hand side of the comma is telling R what you're defining as your rows, and to the right what you're defining as your columns. Now, but R also is designed such that if you leave anyone vacant, R sees it as you are calling up every of it. For instance, now like in line 19, you can see I just put square brackets, comma. So that means that I wrote nothing for I didn't define anything for the row. So R interprets that as all rows to enter. And then another R, comma 5. Now, what that 5 means is I'm telling R to extract the 5th column. Remember, let's look at our iris data sets. I will stop closing so that we really make the point to it. Remember, it has 5 columns, and this is the 5th one, which is what? Species, the species. So this command in line 19 simply tells R to extract the 5th column. And if you run it, you can see it will extract just all of the ones that we have here. Remember, it is this, all of this. That's what R just extracted. Okay, so it means that you can also use this command to extract any of these rows. You can use the dollar sign, or we use the square brackets, and then with the comma, but we won't say anything regarding the rows, and I will now bring up everything. Because if we should define anyone, okay, let's say we are okay to bring up only the 11th one. This is the 5th column, okay, and this is the 11th row. So let's say I want out to bring up just this setosa in row number 11 and under this species. So that means 11 and then 5. So I can decide to run that in the console. So I'll just press my up to bring up the last command, and then I'll just type here 11 and run it. So you see, we'll bring up setosa because that is what is there. And then if I decide to say I want to bring up this one that is in this is column number 3 and row number 10. this 1.5. Let's say I want to call up this 1.5. That means row 10, column 3. So let's modify that to row 10, column 3. So if I say row 10, column 3, I press enter, you see 1.5 is what comes up. So that is how R works. So let's go back. Okay, so can I see that this square bracket accepts numerical characters? Remember when I talked about the kind of type of data that R accepts. R accepts numerical data, R accepts string or character data, and R also accepts Boolean or logical characters. So square brackets accept all. So here in line 19, can see we use numerical. Now in line 20, we're now using character, we're using string. So if, we can decide to, instead of using the number of the column, can decide to call up the actual name of the column. But remember, this is very highly case sensitive. So you must get the spelling and must get the case of the characters for it to work without errors. So if we decide to run line 20, still same as line 19, if you recall, because species is still the 5th column. So line 19, line 20, line 13, or refer to the different ways of calling, of getting the same output. And then line 22, still the same thing. Remember, I told you, okay, yeah, sorry, line 22 is the same thing but different because line 22 calls it up as a data frame, not as a vector. So in line 22 and line 23, we can, without using the comma, we call up we call up what we want, but that would be as a data frame. That's why if we look at the result here, we can see it has, this is the name of the column. It is shown, and this everything there is shown. So this is like a one column data frame. So that is what's that difference between using the comma and not using the comma. So if you run line 3, the system as line 22, it brings it up as a data frame and not as a vector. Okay, what may ask, what's the use of vector or data frame? Well, it depends on what you are doing, or what you want to do, what you want to achieve. Maybe you want to plot a graph, I want to analyze that data. So some data will require it to be in a data frame format for you to now apply the functions to it. So that depends on what it is that you want to do. So, but you need to know which one, what outputs, which each command brings up, so that you will know which one will give you what you expect R to give you. So for line 25, yeah, you just try to repeat it. But so we're now going for sepal length. So if we run this, vector of sepal length, and if we run this, still the same thing, but we're now using, first one was numerical, second one was using character. So I hope I'm not too fast. As I earlier said, feel free to come up at any point if you are lost or if you need any clarification, and I'll gladly explain. Okay, so now we are going to line 28. Now, we've been doing just kind of just one column. Okay, now we can call up as many columns as we want using this concatenation function, the C function. So with the C, you can use C brackets to now call up as many columns or rows as you want. So in line 28, we told R to extract for us the first and the fifth columns. So if we run this, so this brings it up as a data frame. So we can see it has extracted the two columns that we specified. Remember, we use the comma to tell R to extract all the rows, all these rows of data, and not a specific one. But if we had defined any row, I would just bring up those rows specifically, as we will see in subsequent ones. So for line 29, as you can see, we can also still use the characters instead of the numerical. So if you run this, it's still the same thing. The only thing is that but I think I now swapped it. Like with 8, it was 1 and 5. Remember, the first column is sepal dot length, and the fifth is species, is the species. But in line 29, I now put species first, and that's part of the lexicon. And we see that's why R swapped it, because R followed the command as I was instructed. So, but it's still the same thing, but yeah, the columns we are swapped based on the command I gave R. Remember, this comma has to be there. So for line 31, okay, so now I've now moved from defining only the columns to now defining only the rows. So that you see that's why there is comma and then nothing before the closing square bracket. So for line 31, it just tells R extract the first to fifth rows in the array data set. That means the first 50 rows and all columns. That's what that command means. So if you run this, you can see the first to fifth rows all are shown, and with all the columns, every information shown. And so if we now run line 32, we are now defining both rows and columns. So we're not telling R in line 32, okay, extract row number 1 to row number 7, but only bring up 3 columns: a species, sepal length, and petal dot length. So if we run this, you can see that is what will come up. So then we are in line 35. So this one now, I try to write it.
I have a question.
Okay.
The C, is it to call or to concatenate?
Sorry, come again.
The C, is it to call or to concatenate?
Well, to call or to concatenate.
Sorry, plague. Hey, Joshua, congratulate. What you say? I don't know how you said. You and Ian, you push mind yourself. You already know this thing. Why you pay me like what's contabulate and what are you saying?
All right. Okay, to call or to concatenate. Okay. I think Joshua has that much evidence to pass across it also. It might be called, because I remember there is actually a concatenate function in R, concat, C-O-N-C-A-T. So maybe this C is called. Joshua, please correct me if I'm wrong. Hello, Josh.
You're correct, sir.
No, come again. I get you. What is your, how am I correct?
I think in previous classes I can't really remember like what we call C, but I just want to get the difference. And when we use this C, do we use this C to bring species, sepal length, and then petal length together, so that when they are paired in our console, they are paired beside each other, like we bring them together, or we use them to bring them from a particular data set? So I want to get what call is, what concatenate is, and if C, since you said we have concat in and R, then is this C for call?
All right. Okay. I think this is semantics question. Well, C, I know concatenates in Excel language and in Visual Basic languages is to bring things, close together. So, but in R, well, this C may just be to just call and attach them in a particular format. So I don't really know which, I can't remember the exact word to use. Okay, let's just say C. We use C to bring together certain variables or data in R. So maybe I'll check out which the phrase or language used to describe C in R. Because I know R, what we have as concatenates in Excel, for instance, we use paste or paste zero in R or concats in R. So it can be a bit tricky in terms of language, but we know what we're doing, we know what we're coding, but the word to use might be the issue. So maybe I'll check it out, and then maybe next class I may answer the question directly. So Dr. Basa, in response to your question about concatenates, I think that's what I have.
After you finish discussing, see, it's now your come. Oh yeah, concatenate. Explain yourself. Concatenate.
Okay.
I'm making a whole SRS by taxi.
Please, please. If you say congratulate, or be congratulate. Can you explain very well?
Once more.
Okay. So well, the main thing there is just about the C, the use of the letter C in R. It's used to call up. Okay, let me use the word call up, to call up things. I think call sounds better. It might be correct. I think it's called. Should be called, not concatenate, not concatenate. Concatenate is CONCATE.
Sorry, Dr. Yanyi. Dr. Yanyi, can you hear me? Sure.
Okay. Sorry, we had a network glitch. And
hello, Dr. Yanyi.
Yes, I can hear you.
Yeah, C is to concatenate. That's what it means.
Okay, you've checked online now.
No, I didn't check online. That's what I learned when I was learning R.
Okay. Yeah, so I was correct. I was almost
So because obviously you always use it to group things in a box, like put them together.
yes.
So,
Yes. Thank you for that.
So it tells R to treat everything in that box as like a vector or a group, as it were.
All right. Thank you.
Yes.
Thank you for that. So, okay. So, is that someone talking?
I said C means concatenate, right?
Yes. from what the professor also confirmed, C means to concatenate. So it means it allows you to bring things together. So because for instance, now in line 22, 28, 29, even line 35, without the C, R would allow us to call up all these numbers of rows or columns without the C. The C allows us to call so many things and bring them up. So we can concatenate in R using the C function. Thank you, Dr. Francis, for that. Okay, I hope this is recording. Okay, it is. All right. So okay, so
it's not recording, it's not recording, it's not recording. Hey, it's not recording. Oh. Some of us still have to concatenate it later on. It's not recording.
It is recording, Dr. Thomas.
Oh, okay. Because let it not be that when I want to concatenate it, I will not find it. Thanks.
Okay, so concatenate is just an English word, but what it means is that it allows you bring in more than one thing together. So the C function is to concatenate all these things so that R can use them. The way we brought together species, sepal.length, and petal.length. So the C function allows that to happen. So it's very helpful when you're doing anything more than one. You can use it. Even if you want to use it for only one, it still allows you to use only one. But for more than one, it allows. But anything without the C, I would allow you call it, except when you use other functions. For instance, now here we use the colon operator. So like here we wrote 1 into 5. Remember, I did that in our earlier classes. It will just bring up 1, 2, 3, 4, 5. If I write 5 to 1, it will bring up 5, 4, 3, 2, 1. So that's one that you can use without the C to call up more than one. There are other functions. Remember in our other classes where I use the rep function, where you can call up using the rep function. I believe those of us. Okay, I think I can just show it here quickly so that we can like here now, where you can use the rep 1:5. So this repeats this 4 times. So that's the rep. These are areas you can use to call up more than one data or object or variable, and R will not complain that you call up more than one. So okay, I think we can go ahead. So we are in line 35. So let's run line 35. So if we run it, this is what came up. You can see 32. Okay, let me bring it up so that we can appreciate what has just happened. Let me bring this up. Okay. So we can see we told R to call up these rows and bring them together. 32, 54, 55, and then 16 to 20. You can see it all call up here, and also here 101 to 107. It has all done that, but only these columns, only the species, sepal length, and petal length only. So that's what R has just done, and that is how to do that. So with this cut up, you can run any analysis you want to run based on this. So that is what this is for. Okay, so any other question based on this? Because we are going to tougher ones. We are going to using the logical operators, and this might be a bit complex, but it's still very surmountable.
Please go up a little bit.
Okay.
I saw that you put 2 space between the sepal.length and petal.length, and it doesn't affect 2 spaces.
All right. So in terms of spaces, for the spaces, no, R has no issues with that.
Okay.
So let's try it out. We are all here. So I'm going to put spaces. So anywhere we can even put space here. Let's see if there will be errors anywhere. I'm going to add a lot of spaces, but okay, and then this is to, let me see if there will be any error too. Let's see where R will flag any error. And then okay, let's run. So you can see as far as this one is concerned, but you also see that I was careful where I put the spaces, where there were inverted commas. I mean, I didn't touch anything inside those two inverted commas, you know, those two apostrophes, because anything I do there will affect the, remember I said that that space is case sensitive, that the character, the string you put there must be the same as the name of the column or variable. It must be the same. Anything different, nothing may come up, or R may come up error, you know, or that's, it will affect the output. So I don't know if that answers your question. Oh, I'm just seeing some comments. Sorry, I wasn't seeing comments earlier. I mean chats. Okay, I can see Dr. Francis said congratulate. Oh, sorry, I didn't take that earlier. Then Dr. Mani asking what does that mean? Okay, I think that should be Dr. Mani or Dr. Batat writing. Dr. Mani, I believe. Okay, Joshua said call means make up. Okay, like okay, or it may be a rule. Okay, all right. Thank you for the chats. Okay. So let's go to the logical operators. Now it gets a bit more exciting. Let me use that word. Okay, I have a direct message from Dr. James about script 2, art tutorial 2. I think I did. I sent art tutorial 2. I did. It's in the group, Dr. James. Am I audible? Oh, okay. It's there. Sorry, I've been told that that the rep function wasn't there in art tutorial 2. Oh, okay. So maybe we quickly just run through this rep. I hope am I audible? Those outside of the conference room, please.
Yes, yes, we can hear you. Thanks a lot.
All right. So sorry, let me confirm. For our tutorial 2 that I sent to the group, we didn't do all these sequence and rep. Sorry, am I hearing anyone talk?
Checking the script. I could not find it in the script.
Okay, that means I will send this out to tutorial 2. Since we did, I won't have to repeat this rep function. All right, thank you for that. Okay, so let's go to the logical one. So for line 41, so bear in mind what I earlier said, that when you're using square brackets, you know, you can use it with a comma or without a comma, and it accepts numerical data, it accepts string or character, it also accepts logical characters. So now the square brackets is such that if you want to use logical operation on it, it will only return what is true. Anything that is false, it will ignore it. So that means that you will fashion your logical operation such that it will show true, so that what you want is what will be true for that operation. and that is what we will now show in the square brackets. And remember that the rule still stands that anything to the left-hand side is defining the rows. And anything to the right-hand side of the comma defines the column. So for line 41, what it means is that, okay, we should just we should just focus on this alone. Okay, so that is the row definition. It simply says, is iris dollar length equals to 5.4? That is true or false. So it means that it would check through everything in iris length and return true or false for each one. So let's just run this alone first. Remember, in R you can run only what you want, apart from, so one select and run. So let's run this now. If I run this now, you see what has just come up now. So you can see, so it tells me everything separate on length. You know, it has this comes up as the vector. So it has a total of this is 150 number of data, so to say, you know. So it tells me which one is true. That means that, so it means that only the ones that are true are the ones that are equals to 5.4, while the rest are false. So what it means is that for line 41, it is just telling R to go to the iris data set, and then rows that are equal to 5.4 is what should show. And then show everything for the columns. Remember that for the comma, right-hand side is empty, means that it will show all the columns. So now, if I start to now run the entire row, the entire line 41, now this is what has shown. And that is for, you know, you can see that row number 6, and if you check it here, it is 1, 2, 3, 4, 5, 6. 6 is true, so it showed 6. And this one too, you know, shows like row number 6, 11, 17. This is some that they are the only ones that are true. And if we want to confirm, you can see that these are 1, 2, 3, 4, 5, 6. So only 6 rows are true. And I can see that this is 1, 2, 3, 4, 5, 6. So it has brought up what we want. But we now used logical operation to ask R to give what we want. So simply put, what we ask R is to give us the data of everything where the separate length is equal to 5.4. That's for line 41. I hope that's clear enough. Okay. I believe it's okay. To line 42 is the same thing, but we now also define the columns too. Only column 5, 4, and 3. So if we run that, so that is it. Column 5, 4, and 3 has come up. But remember how they already defined the rows that must show. The rows is defined based on the separate length being equals to what? 5.4. Then if you go to line 43, and now I introduce another logical operation, logical operator. Apart from the equality sign, you know, this is the equality operator. This double equals to is the equality operator. That is the equality logical operator. Then this is and is also the logical operator. So and is telling me that this and this, okay, and you know, if we may remember our maybe further math, we may have done further math in the past. It's still that's logical rule still follows here, in that true and true is equals to true. True and false is equals to what? So once there is false, it is false. So true and false is false. False and false is false. So it's only true and true that is true. So, but I don't want to confuse many of us who may find this a bit tricky. So what I'm trying to explain here is that when you use the AND logical operator, you're telling R to fulfill, to bring up what you want when this is true and this is true. So once anyone is not true, then that is false. So R will see that as false and will return nothing. Let me go to it again. This first command is telling R to is asking R is a what? Is asking R is check if each of separ.length values is equal to 5.4. If it's true, then tell me it's true. If it's false, tell me it's false. That's it. Then this one now tells me, this one now tells me, check if each of petal.width values in the iris dataset, whether each of them is equal to 0.4. If true, then return true. If false, then return false. Now, I'm not bringing up two of them. So only return when this is 5.4 and this is 0.4. That means that both conditions must be fulfilled for you to have true and for a value to be shown. Now, let me break it down. Let's look at the iris data set. Okay. Now, look at this. Separ.length must be 5.4. Let's look for separ.length equals to 5.4. You can see line 6 is 5.4. Okay. So this satisfies is true for that first logical operation. Now let's look at petal.width equals to 0.4. Petal.width. So you can see that line 6 fulfills both operations. So line 6 must be there in our answer, surely. But other ones will be absent. So, but if, for instance, now, we may have one, like now, see line 11, this is 5.4, but this is 0.2. So this will not show because only one was satisfied. The other one is false. So it is false. Now let's run the entire line 43. But remember, I also added that don't show me the whole column, just show me only column 5, 4, and 3. So if I run this, you can see line 6, 17, and 32 fulfilled all the logical operations that I told R to check. So only look at the data that satisfies both. So this AND operation, this AND operator is what tells R that both must be satisfied for it to give the results. I hope that's clear. It's important for us to understand this because we're going into logical operations. It can be a bit complex, but if you understand this, then we are good to go. Dr. Basa, hope this is okay. Can we go ahead?
You are good to go. You are good to go.
All right, thank you. Okay, so now we have line 45. This is the OR operator, OR. So this is AND, and then this is OR. So this or this. So if you remember in our programmers those days, so what gets OR, true or true is true. True or false is true. False or true is true. The only false or false that is false. Okay, so if you can understand this, then it means that this command is telling R if species is setosa or if petal.width is 2.2, bring it on. So anyone that is satisfied either way, it's fine. So anyone, both or any can be satisfied, and you bring up that part of the data. Okay. So, but you can see here, I use the greater than operator. I didn't use the quality operator. So this means that beta dot width should be greater than 2.2. So it means that anyone that is satisfied, bring it up. So if we should run this, so you can see a lot are satisfied, So you can see that, remember it could be setosa, it could not be. So it means that anyone that's not sedosa means that it's satisfied this second one. You can see Virginica, mean that all these ones, the beta dot width must be greater than 2.2. And you can see they are all greater than 2.2. So that is for this and then these all logical operators. I hope I didn't confuse you guys. Can we proceed? Oh, already time 4:30. Can I rush through this? Okay, let me see if I can. So, any questions so far? Okay.
You don't need to write anything. No.
Okay. So, what do you want me to do, sir? Any question? Well, we are behind schedule already 4:30. So, do we stop here? This is just small. Okay, let me quickly rush through this. It's not that tough, I believe. Okay, for line 48, I introduced the negation sign. Remember this. So this gets even more complicated. Remember that the square bracket will return true. So when you now say negate true means false. So what is false? That means R will ignore that one that is false. So it now means that I'm now telling R, it's a bit complex, but try to follow me now. For line 48, it says for in the array data set, let separ dot if separ the length is equal to 5.4, then it is true, return it. But no, false, opposite of true. That means anyone that is true should be false. Anyone that is false should be true. So it will instead show the reverse. That means bring up anyone that is not equal to 5.4. That's what the whole of this logical operation means. It means bring up the rows where separ.length is not equal to 5.4. That's just what this means. And so, but like in line 49, there's something. Okay, but I showed that R can allow you to put the negation sign either in front of the logical operation, or you remove the first equal to sign and put it there, and that is good to go. So now if we should run this, so you can see that means that we are sure not to find anyone that separate the length is equals to what 5.4. So that is what this means. I already defined what should be the output, the columns 5, 4, and 3. So this is still the same thing. I only changed the position of the negation sign. So similar thing is also in line 51. I instead did the less than sign. This is less than 5. So with this negation sign, it means what? Greater than 5 is what we show. So I'm now negating less than 5. So that means that anything that is not less than 5, it means greater than or equal to 5. That's the opposite of that. That's what R will show. So, and then here too, okay, so there's a new function here, call names. I don't want to go too much beyond time, because I know we all have other engagements. Call names is a function to just call up that means the column name, the names of the columns in a data set. So I just told R to check up the column names in Iris, then one that is equal to species we wanted to bring that. So I'm just trying to show how you can use logical operations to also define columns, not only defining rows. So we can use the call names function to define the columns. Okay, So I think we can stop here for now. So
Please, let me ask you a question.
Okay, please go ahead.
What is the comment in line 51?
Okay. So what's it about the comment? Any issues?
Yeah, I know I asked question about it earlier, but I still want to ask for that question.
Okay, you want me to
read it out? Yes.
Okay, extract only columns 1, 5, 4, and 3 in the HRH data set where it is true that sepal dot length is not less than 5. Okay, that's only what I explained.
Yeah.
Okay, go ahead. Okay, what is confusion there? Or do I repeat? Do I re-explain line 51?
No, sir. No, sir.
This no, sir, is not clear. I don't think you are yet confused.
I think it's the more I look at it, the more I get to understand it.
Joshua, I didn't get you. Come again.
So the more I look at it, the more I get to understand it.
Okay, so it's a bit clearer now.
Yes, sir.
Okay. So just take your time, calm down, understand that this negation sign, negates this. Okay, this negation sign means not. So anything that is not this. And remember that the square bracket returns true.
Yes, sir.
So anyone that's at the operation, for instance, now maybe this returns true. Okay. The negation sign will make that one false. Once it's false, I will not pick it. So I will pick the opposite one. Now the common true, I will pick it up. So all these things become useful when you have data sets that is large and you don't want to just on just a small number, and you want something that will just help you bring it up and just calculate and give it. So just on the command R, bring it up and then return it. So that is what R will do for you in this case. So yeah. Okay. Any other question, comments from anyone? What we call it today? Because we are getting deeper and deeper, and we need to get this background as we go back and start running longer codes and all. Okay. In the absence of any other, I would like to thank us all for being here. So see you next week. I thank SRS for being here. We have SRS and Dr. Basa. Yeah, I think they are 2 in 1. Yeah. Thank you for being here. Okay. See you all next class. Thank you.